is likely to change the whatever happening in terms of extreme events, and that will intensify all these processes across. That is why it is very important to have an understanding about what has happened historically till 2025 and so on, and what is likely to happen in future scenarios under different scenarios as well. Whether it is low emission scenarios, whether it is moderate emission scenarios, and whether it is high data sets are very important. Very important. Time series data sets are very important because it gives you an idea about in the time how different properties are behaving with respect to different time intervals. For example, if you look at this particular graph, it tells you about there is a random fluctuation of the time series around the for different time intervals like that. So that is called a purely a random processes. However, if you look at this particular graph, this tells you about the process
बोलू हेलो
थोड़ा पीछे चलता है। नहीं नहीं लाइव तो सब
हाँ
होना है।
हेलो हेलो
एक सेकंड अब आएगा, इसने एडजस्ट किया ना, थोड़ा सा पीछे चलता है।
हेलो हेलो
सर हेलो हेलो लाइव आएगा, इसका फिलहाल नॉर्मली आ जाएगा। हेलो हेलो ठीक इस चीज़ का ध्यान रखना।
So we discussed about the time series data set. So let's back to the basics again. When you are talking about the climate extremes, what is the important thing is time series data set. What is time series data set? The data set which is we are collecting in different time interval. It could be your annual data, it could be your monthly data, it could be your daily data, like that. So basically when we are talking about the time series data set, it is a collection of the data which we have recorded in different time period, and we are representing that data for to know about their fluctuations. Okay, so the long term, when you are looking at this particular data set, we are looking at the long term mean, and this long term mean tells you about the long term behavior of your climate extremes or different types of climate variables, or if you talk about, let's say here, temperature, rainfall, etc., like that. And the fluctuation around these different types of long term mean is basically called the random fluctuation around the data set. In the mathematical formulation, we can basically represent this time series data set in terms of xt is equal to the long term mean, which is the deterministic component, and there is a stochastic component or random component of your time series data set. Now the time series data itself can be divided into multiple parts. I have shown here only the 4 types, but there are multiple types of the time series data set can be possible. The first one is purely stochastic. The second one is where we have a trend in the data with your basically the random fluctuation around that particular trend. The third one is basically we are talking about the periodic fluctuations with the random fluctuation around that particular data set. And the fourth one is basically the stochastic data plus jump. So jump is basically where we have the long term mean behavior has been shifted to some other level. It could be vice versa also. Here it is shown that the long term mean has been increased significantly, but it is also possible that the long term mean has been decreased significantly. It is basically suggesting that there is an abrupt behavior of the hydrological property in that particular region. There are something abrupt has been happened, and that has basically abruptly changed the hydrological behavior of that particular regions, like that. When you are dealing with the time series data set, here we are basically looking at the different types of realization of the data set. Let's suppose you have collected the data from 1901 to 2025. You can divide your data into, let's say, 1901 to 1925, 1926 to 1950, 1951 to 1975, 1976, and so on. So this is called a realization of the data set. Why we do this? Let's suppose somebody will tell you about, okay, there are significant change in the climate properties in one particular region. How do we prove this? Then when we have to when we divide our data into different realization, we can compare what happened to the long term mean, what happened to the fluctuation around the mean, and what happened to that particular, if there is any jump or any kind of a deterministic fluctuations around that particular time series data set. So that is what it is important, where we look at different realizations and then we can compare with all of these different realizations, and then we try to understand that from which part or from which time period we have observed there is a significant change in the time series data set in different realization terminologies like that. The another term important aspect of collecting the time series data set is forecasting or projections of the future. Why we do that? Basically, let's say we have a length of the historical record, since let's say here we are collecting the rainfall or discharge data from 1951 till 2025, and let's say we are using this data for a particular project. So here the economic life of the project is more than the data collected record, and therefore we need to do some sort of projections of the data set so that we can match towards the end of this project what would be our hydrological behavior or climate extreme behavior like that. So therefore the future projection is, that is why it is very important, because we are trying to look at how this project is going to be affected by long term fluctuation of your climate change or any particular hydrological variable in the future terms, and then we can basically change our operations or different types of project operations accordingly. So this is basically a kind of a flow data. Let's assume we are measuring a flow in a one particular locations for different time period, and then we are basically, this is a random fluctuation and this is the mean flow. We can basically look at this particular historical behavior and you can try to predict for the future terms as well. How do we do that? Let's say we have 1970 to 2010 data set and we are trying to extend our data for 2040. So this is basically the known part, and then this is basically the forecasted or unknown part. How do we do that? Basically we divide our data into two parts, calibration and test data, and then we try to look at some forecast error, and then basically we calculate some sort of mathematical formulation, and then we basically try to calculate the error associated with the forecast and projections. So this is basically the climate change, how the climate change are likely to be affect the extremes by looking at the, let's say, time series data set. How we are going to tell about whether the extreme has been changed or not, what kind of the procedures. So far we have already discussed like that. Now the next part of the time series data set is called frequency analysis. Frequency analysis is basically we are trying to look at particular data set about their probability of occurrences. What is the probability of occurrences? So if you toss the coin, let's say, what is the probability of occurrence of head? 1 by 2, 0.5, right? And what is the occurrences of tail? Is 1 by 2. So let's say you replace the coin with dice, and if what is the occurrences of, let's say, 6 is 1 by 6, right? So similarly, the probability of occurrences means what is the chance of occurrences of one particular event. Now you just extrapolate this concept to the extreme climatic conditions. How we can calculate the probability of occurrences of extreme events in terms of their magnitudes? Can we calculate the magnitude of 100-year frequency flood? 100-year frequency flood means the flood event which occur once in 100 years time period. What is the magnitude of that particular flood? So here basically comes the frequency analysis, where we basically look at the hydrological problem and we basically characterize by their occurrences of the extreme events like that. For example, we talk about extreme events, extreme floods, extreme precipitation events, and low flows also. So particularly when we are talking about the frequency analysis, we are interested in extreme values either in high direction or either low extreme direction, and then what is the magnitude of extreme events which are proportional to the frequency and occurrences. So for example, if you look at this particular figure, it tells you about that. This is the parent distribution. Let's say you are recording the rainfall or discharge or temperature data at one particular point. You have collected the data set. There are two different extremes in the data. One is we call high extreme end, the another is called low extreme end. High extreme end, where if you look at this, where the x values are very high, the probability of occurrences are very low, right? So this is a kind of a extreme events we can classify. Another way, if you look at here, the low magnitude direction, here this is the very low kind of the data set, and the probability of occurrences are very low also. So that is called the low extreme flows. When you are talking about high extreme flows, for example, you are talking about extreme precipitation events. Extreme precipitation events means when the magnitudes are very high and the frequency of occurrences of that particular magnitude is very low. Low extreme flows are basically, let's say you are talking about drought events, or basically you are talking about some sort of very low flows events in a particular river basins, where the occurrences of that particular extreme events are very low, like that. So how do we handle this frequency analysis using some sort of distribution functions? So basically, how do we do that, this frequency analysis? We have to apply some sort of distribution functions, density functions, and we have to calculate the probability which are associated with different magnitude. So this is the one example of the you aware about histogram? What is exactly histogram? So what is histogram? Distribution of the data set. Okay. So you are dividing the data into different parts. For example, let's say your data set is varying from 0 to 100. You are saying that, okay, I am taking the data 10 bin size, 0 to 10, 11 to 20, 21 to 30, and so on, right? This bin size you are dividing the data, and based on this division you are calculating how much values are present in different bins. How many values are present in 0 to 10, the total number, and there 11 to 20, the total number, and 21 to 30, and so on. Once you have this total number values for different bins, you can make this kind of the graph, which is called histogram. Histogram is basically you are trying to estimate the frequencies of points with respect to different bin size, and you are plotting this data set in a particular graph style. That is basically called the histogram. Now imagine if you are considering this bin size 0 to 10, but you are consider, let's say, this bin size so small, is very small, that is, then it will become like a probability density function, where the bin size is very smaller. And there is another difference between the histogram is, histogram directly gives you the probability, okay, because let's say you have one bin size where you have values around, let's say 20, and their total number of values is 100. So what is the probability of occurrence? 20 by 100, right? That is 0.5 or something like that. So but that is your probabilities, but when you are talking about the probability density functions, it basically tells you about the probability densities rather than your probability values. So when you are applying this probability density function for frequency analysis, there are certain conditions we have to always remember. The probability values are always equal to 1. It cannot be more than 1, right? So if you just add a coin, tossing of coin, there are two conditions are possible. One is your occurrences of head, one is occurrences of tail. 1 by 2, 1 by 2, if you add, that is equal to 1. Similarly, if you do the similar exercise for your hydrological data series or climatological data series, you are calculating the probability of different extreme events. If you add all these values, it will always gives you 1. So that is the first condition of the any functions to be a probability density functions. Then there is another condition is whenever you are using the probability density functions, it has to be greater than 0, which means probability cannot be negative number. It is always a positive number. So this is basically the two conditions are very important when we are choosing any kind of the probability density functions for your flood frequency analysis. So there is a two forms of the probability density function. One is called the PDF and another is called the CDF, the cumulative density function. The probability density functions are basically that directly gives you only the probability density values. Cumulative density functions are basically those, cumulative distribution functions are those which directly gives you the probability values of different extreme events. So it is always, you can see that this curve is always a kind of a S curve, right? So here the minimum value is 0 and maximum value is 1. When you are approaching towards 1, there are the region where we have lots of extreme events. And here also when we are approaching here where the probability is a very low and there is a low values, that is also we call the extreme events. That is how basically we differentiate between the PDF and CDFs like that. Now we are collecting the extreme events. How do we define the extreme events? So as we just we discussed about all the data set we are collecting in the time series format. Okay, so time series format means we have a time window and for each time window we are collecting the data points and we are plotting the data points in terms of time series graph. If you look at this data here, you can see that there are lots of values which are crossing above certain thresholds. Okay, so basically there are two ways where we can define the hydroclimatic or hydrological extremes. One is called the block maxima approach. You can write down this block maxima approach. What is block maxima approach? So you consider a block of the data set. Let's say you are using 1 to 365 values. Suppose you are measuring rainfall, flow, temperature or any particular hydrological variable, and that is basically you are measuring daily level, daily scale. Okay, so for each year you have 365 values or 366 values. Okay, let's imagine we have only 365 days. Fix the 365 days number. So the block size would be 365 days. 365 दिन का एक block size बन जाएगा. For each block size we are referring that what would be the maximum value for that particular block. It could be 365, it could be 100, it could be 200. It depends upon you what kind of the block size you are using for that particular extreme events, identification of the extreme events. So the most general way is basically yearly block size when we are considering what is the total maximum value for one particular year. Okay, that is called the block maxima approach, where we are highlighting for each different blocks what is the total number of maximum values. So this is particularly called the block maxima, and this is basically called threshold based method, which is called peak over threshold method. Peak over threshold method is basically we are using some sort of threshold values, and based on that, if the values is crossing above that, we can consider as a extreme events. So this is the two ways you can basically differentiate, or you can basically extract the extreme events information from your time series data set. Now you will be able to extract the time series from your, if I give you the data. How I define the? Yes, threshold is basically a very subjective thing. Let's suppose it can depend upon region to region as well. For example, you are talking about urban areas where 100 mm or more than that rainfall can be considered as very hazardous. So in that particular region, 100 mm can be a threshold. That is basically, yeah, minimum rainfall amount is 2 mm. That is for the lower minima. Dry day and wet day. But we are not specifically focusing on the dry and wet.
we are focusing on the extreme events. Okay, so extreme events can be classified as a predefined value threshold, or it is possible that you can think about a selection of that methodology where getting the extreme events which are not dependent with each other. इसका मतलब ये होता है, let's suppose today yesterday we have received a very significant amount of rainfall, and today we also receiving a very significant amount of rainfall. It might possible that these two events are related to each other. How? Because these two events are evolving from the same synoptic system, same climatic fluctuations. Okay, so that is why it is possible that these two events are dependent. I will tell you another example. Let's suppose you have a river where you are measuring river discharge, and at certain point, let's say during the monsoon, you observed a very significant amount of flow, है ना? In the next day you are also observing very high amount of flow. It is possible ना कि एक दिन अगर बहुत ज़्यादा flow आता है तो of course अगले दिन एकदम zero नहीं हो जाएगा. It will have very high amount of flow as well. But it is possible that the first flow might you can consider as extreme events, but the second flow is actually dependent upon the first day flow. Why? Because it might possible that the first day flow has been already saturated the grounds, and therefore even the smaller amount of rainfall can create more significant amount of discharge. So therefore these two events are sort of dependent events, and when these are dependent events you can consider only single events, because dependent events if you are consider, you are violating the rules of the probability density functions, this extreme value theory. So therefore we consider the threshold in such a way that these events whatever we are getting should not be interdependent. It should be it should be independent in the nature, like that. Or sometimes of threshold we select based on some sort of ground level informations, like that. So क्या चीज बेस वैल्यू वही तो हम समझा रहे हैं ना. बेस वैल्यू इज हियर इज 60,000 क्यूमेक्स वी आर यूजिंग, राइट. It is based on some subjective knowledge. Okay, here I am just giving you one example. It can be 60,000, it can be 80,000 as well. It depends upon site to site. Let's say there is a bankful condition. River की bankful condition होती है ना कि हर जगह कैपेसिटी अलग अलग होती है. We cannot compare Ganga in the upstream and Ganga in the downstream conditions, right? So the water level or bankful conditions will be different. So therefore your values will also be different, like that. So it's a site specific. It is also based on your dependence and independence criteria as well. कि अगर हम एक threshold बना रहे हैं ना, अगर let's say you draw the threshold here as well, there are multiple events you will also classify if you lower down this threshold. तो उस केस में ये होगा कि you will have multiple extreme values which are dependent to each other. तो जो dependent to each other होगा, then what will happen? You will have some sort of violating the extreme value theory that we will discuss about in the next slides. What is that? So now you are able to understand that you will be able to extract the block maxima based approach, the peak values, or the peak over threshold based approach to identify the extreme events. है ना? These extreme events can be either you can use as a single variable or bivariate or trivariate and etc. If you are using single variable, it's a single climatic extreme. If you are using two variables together, it could be your compound extremes. So now you have, let's say, multiple extreme events you have classified. You can make the probability distribution functions of this, and this is, let's say, the parental distribution of the data, and the extreme edge of the data set is considered as your the probability occurrences of the extreme events, like that. So similarly, what we have just explained in the previous slide. So if you look at the probability of occurrences, here you can mark these probabilities, and here you can see that the probability of occurrences of different extreme events, like that. So when you are talking about the extreme events, extreme values generally do not model based on the regular probability density functions. That requires a special case of extreme value distributions. So these are called extreme value distributions. There are three types. One is called Gumbel distributions, second is called Fitchett distributions, and third is called the Weibull distributions. These distributions, this is the shape of the distributions, how you can look at how it basically behaves. When you are talking about, so these distributions are function of generally three variables. When your eta value is equal to 0, this will become your Gumbel distribution. When your eta is greater than 0, that is called the Fitchett distribution. When eta is less than 0, that is called the Weibull distribution. Okay, so this is how basically we demarcate these different types of distribution functions. So if you look at this Weibull, Fitchett and Gumbel distributions, it is basically looks like this function, almost similar. But if you look at Fitchett, for example, it shows that this is the high heavy tail distributions like that, where the probability of occurrences of extreme events or extreme events are basically very high probability of occurrences in particularly Fitchett distributions like that. So this is another experiment here. You can also do if you know the R MATLAB or any particular programming language. So here basically you can take the normal distributions data set. You can extract this extreme values based on block maximum approach, and you can make some sort of distributions. This distribution will always comes as a Gumbel distribution. If you take the values from the exponential distribution function, and if you just extract the maximum value each time, you will get some sort of again a Gumbel distribution. But let's say if your parent distributions are basically a uniform distribution and you are extracting the extreme values, that will basically consider will behave like a Weibull distribution. So this is some sort of experiment you can perform. Basically you consider one variable as a normal or Weibull or normal or some different types of exponential or uniform distributions, and take out that extreme values from these distributions, and based on that you would be able to calculate what is the extreme value distribution behavior based on this data set. So when you are talking about these distribution functions, we generally treat the extreme values based on some sort of extreme value theories. Extreme value theory or extreme value distributions are primarily the Gumbel distributions, Fitchett distributions and Weibull distributions. Okay. There is another generalized form of this distribution is called generalized extreme value distributions. So where all these three forms are, we club it together, all these three forms, Fitchett, Gumbel and Weibull together, and then basically make some sort of generalized extreme value distributions where we can classify this is type 1, type 2, type, and this is type 3 based on their different functions like that. So this is all about how we are dealing with the extreme events. If you have any questions, you can ask. Generalized distribution क्या है? हाँ. So basically, so suppose let's say you have collected the extreme value. ठीक है? अब extreme value distribution जो extreme value theory कहती है उसमें तीन तरीके के distribution होते हैं. Gumbel होता है, Fitchett होता है और Weibull होता है. ठीक है? अब एक एक करके सबको हम फिट करेंगे तीन को. That is one approach. There is another approach कि अगर हम इन तीनों का एक जनरलाइज फॉर्म बना लें और उसको एक साथ उसमें हम फिट कर दें और वो उसी हिसाब से ट्रांसफॉर्म हो जाए जिस हिसाब से डेटा है. सो दैट इज कॉल्ड जनरलाइज एक्सट्रीम वैल्यू डिस्ट्रीब्यूशन. वो अपने आप उस टाइप को असाइन कर देगा जिस टाइप को आपका डेटा है. दिस इज हाउ बेसिकली वी कैन model the data based on their different types, and that we will be able to get the overall picture of the distributions. For example, हम distributions क्यों निकालते हैं? हम किसी डेटा को डिस्ट्रीब्यूशन में फिट क्यों करते हैं? Anyone can answer? Why we fit the data in any distributions? हाँ एक्सट्रीम वैल्यू लाने के लिए तो ठीक है. What is the, चलो हम एक्सट्रीम वैल्यू को फ्रीक्वेंसी ऑफ द डेटा सेट, एक्सट्रीम को भूल जाओ. अभी कोई भी डेटा हो सकता है ना. अगर हमने रेनफॉल कहीं मेजर किया है तो उसको भी तो प्रोबेबिलिटी डेंसिटी फंक्शंस में फिट कर सकते हैं ना. तो वो हम क्यों कर रहे हैं? वो हम इसलिए कर रहे हैं क्योंकि हमें पता चलना चाहिए कि जो 10 mm की रेनफॉल है या 20 mm की रेनफॉल या 50 mm की रेनफॉल है, उसकी प्रोबेबिलिटी ऑफ अकरेंस क्या है. क्योंकि अगर हम प्रोबेबिलिटी डेंसिटी फंक्शंस में फिट नहीं करेंगे तब तक हमें पता ही नहीं चल पाएगा ना. अब ये कोई सिक्का तो है नहीं कि हमें पता है कि भाई हेड आएगा तो 1/1.2 होगा. अब 10 mm का कितनी प्रोबेबिलिटी होगी हमें नहीं पता. इट इज ऑल्सो पॉसिबल दैट इन सम रीजन 10 mm, 20 mm, 50 mm probability is completely different from other regions. Let's take example of, let's say, Masin Ram and some region in Rajasthan. It's completely different distributions. So sometimes we fit the data in these, fit the distribution in the data set, and then we try to find out what is the statistical, behavior of these two regions like that. In region में किस region में extreme रेनफॉल या एक्सट्रीम फ्लड या एक्सट्रीम ड्राउट आने की संभावना कहाँ पे ज़्यादा है, लाइक दैट. ओके, सो दैट इज व्हाई वी बेसिकली फिट द डिस्ट्रीब्यूशन इन योर पेरेंट डेटा सेट, एंड सिमिलरली वी फिट द डेटा सेट फॉर योर एक्सट्रीम वैल्यू functions or extreme value data set for using some sort of extreme value distributions. हाँ, fit the data. हाँ, yes. And then once this data set is fit, basically this distribution functions are fit, we basically calculate what is the probability of occurrences of different events. Let's understand differently. Let's say we have the rainfall data for Indore, Bhopal, or Lucknow or Delhi, like that. We fit the extreme value distribution for all these different cities, and then we will compare what is the probability of a particular event which is crossing above, let's say in one day 100 mm. एक दिन में 100 mm बारिश होने की संभावना किस शहर में सबसे ज़्यादा है. इस बात को कैलकुलेट करने के लिए हम इन फंक्शंस का इस्तेमाल करते हैं, और उसके बाद हम उनकी प्रोबेबिलिटी कैलकुलेट करते हैं. तो उससे हमें पता चल जाता है कि उसकी प्रोबेबिलिटी कहाँ पर कम है या कहाँ पर ज़्यादा है. इससे हमें पता चल जाता है. हाँ, so it is possible that in one extremes, in one region, the lower magnitude is the extremes for that particular region. In the other regions might have a very high amount of extremes that can be considered as extreme conditions there. और इसको अलग तरीके से भी हम देख सकते हैं. Let's suppose in one city, let's say storm water management systems are not very efficient, so that the low amount of rainfall can also trigger the urban flooding there. That is why we have to upscale our system there so that we can manage it properly. That is the ground application of these kind of the theory or applications like that. Now this is all about extreme events, time series analysis of extreme events, how we do some sort of frequency analysis of extreme events. Now what is exactly compound extremes? Compounding क्या होता है? What is compound interest? Have you heard about compound interest? Simple interest, compound interest? हाँ? चक्रवृद्धि ब्याज हिंदी में बोलते हैं. हाँ. इंटरेस्ट पे इंटरेस्ट लग रहा है तो वो बढ़ता जाता है, एकदम कंपाउंड हो रहा है. कंपाउंडिंग. So compounding is basically, when you are talking about compound extremes, it is actually we are taking similar meaning from the compounding interest. where there is a one extreme, there is another extremes. When we are merging it together, it will amplify the effect of both the individual extremes. अगर वो दोनों एक साथ हो जाती है ना, तो उसका इफेक्ट बहुत ज़्यादा टाइम्स एम्पलीफाई हो जाएगा. So that is what exactly the compound extremes meaning is. So for example, if you talking about only drought conditions, it might have certain amount of losses we can see, but let's say the drought conditions are also coming with the hot extremes, heat waves. It might affect more drastically to that particular region, or maybe socioeconomic things we can see that would be changed there. So that is what we call the compound extremes conditions there. So we can see this example, and we can basically we will be able to understand what is exactly compound extremes. So let's say this is total precipitation amount we are measuring in a certain region. Okay, and then you are also measuring the temperature of that particular region as well from, let's say, 1965 to 2020, and 1965 to 2020, that is temperature. Now you are calculating different thresholds. Okay, so for example, you are saying there is a moderate values, there are severe values, and there are exceptional values. यहाँ पर वो clear नहीं हो रहा है. These lines are not visible because of some problem with projection. So there are some values. For example, the temperature here. So when you are talking about the exceptional event, there are few data points were exceeding that particular threshold. Okay, there are severe events, there are few data points which are exceeding that threshold, and there is a moderate, lots of data sets which are crossing above that particular threshold. Similarly for the total precipitation as well, where for the exceptional condition there are few events which are crossing above that particular threshold. So when you are matching, when in that particular historical period when we have a very high total precipitation amount, or total precipitation amount is exceptionally low, for example here, and we have very extreme the temperature conditions. When you club it together, these two conditions, you will be able to find out there is a one event here, one event here, one event here, which is basically considered as a moderate. There is another event here which is called 1980s, where both the events were severe, and there is a one event here in after 2000 which we have observed that both the events were exceptional. You got my point? अभी निकाल लोगे कैसे होगा compound extremes? How do you find it? So basically, let's say you have temperature data, you have rainfall data, you have marked the threshold. So that is, let's say, exceptional threshold, above which you are measuring certain values, and then you are also measuring when this particular precipitation was so low below this particular exceptional threshold, and then you are matching both the events which are happening at the same time. Now you can observe that in 2000, after 2000, there is a one event where both the events were exceptionally high in nature, exceptionally high in terms of temperature or exceptionally low in terms of precipitation. तो ये some sort of क्या condition बनती है, इसे कहते हैं compound, dry and hot extremes. It has to occur for this condition. It has to occur in the same month or same day, same year or same day or same month, whatever the time series data we are considering, है ना? Exactly on the same day or exactly on the same month. But it might also be possible, you can think about compound extreme as a cascading events. It is also possible that there is a drought event, and subsequently after one day or after 1 month you have heat waves, or vice versa, like that. Cascading in compounding, cascading. Compounding is basically we are referring to the events which are happening at the same time. but it is might be also possible there is a lagged effect, है ना, lead and t minus 1 and t plus 1, something like that, lag events like that. So this is how basically you can calculate the compound dry and hot extremes from the data set. Okay, once you identify which is the exceptional event or severe event or moderate event, you can mark those event, and then basically you can basically count those numbers, and then you can think, okay, so for example here you can see that after 2005 there is a many compound extremes we are observing, which means after 2005 there is a significant rise of the number of compound extremes in this particular regions like that. We will also talk about the Bhopal case study, and there I will show you that how frequent these compound extremes have been coming in that particular region. Now when you are talking about these different events, once you have classified these events, you can also calculate the severity level of the compound extremes. Severity level means it will tell you about what is the level of the severity of these extremes. If both the events are severe, for example here we have classified based on some sort of theoretical definition, severe, moderate and exceptional, like that. It can be also be quantified. कोई जरूरी नहीं है 3 classes में ही होगा, it could be multiple classes as well, right? So therefore we can derive a number or value which is called some sort of SCI index or severity index, like that, and this severity index will further classify your extreme events or compound extreme based on different classes. Now you can make these severity classes from, for example, 0 to -1 is your mild, -1 to -1.5 is moderate, -1.5 to -2 is your, let's say, severe, or -2 to below let's say -3, like that, is called your extreme compound extremes. So this is basically how you can calculate the frequency of occurrences of the compound extremes as well as their severity based on your compound or data set. So how do we calculate the severity? It is basically the function of the joint probability density functions. When we will do that exercise, so I will demonstrate how do we calculate this joint probability out of 2 different variables. SCEI is kind of a severity index. Okay, so it's a sort of severity index which is basically defining the severity of your compound extremes. Now this is example of Bhopal. This is a Bhopal districts in Madhya Pradesh. Here what we have done, we have used some sort of climatic data set, historical data and some future projections. I will only talk about the historical part. So historical analysis, what the data set we have collected, precipitation and temperature, and the future we have collected the data from +2 degree and +4 degree, like that. And for historical conditions we have calculated standardized precipitation index, standardized temperature index, and then based on that particular index we have defined the threshold, and based on that we have calculated the occurrences, and then basically the severity. Then basically we club it together and find out what is the overall interpretation of these results. This is one of the example of the compound extremes of temperature and rainfall for the Bhopal districts. Now you can see that what is this actually. So for example, this is the P30 and T70 value for the Bhopal. So basically here you can see that what is P30, you know, percentile, 30th percentile, 50th percentile, 70th percentile, like that. Suppose you have data set, you can calculate the percentile values for that particular data, right? So that is similarly you can calculate the 30th percentile for the rainfall and 70th percentile for the temperature. Okay, so 70th percentile serve as a threshold for temperature, and 30th percentile is served as a threshold for your precipitation. Okay, so whenever temperature goes above the 70th percentile, that is a kind of an extreme event in terms of temperature, and whenever the precipitation goes below the 30th percentile of the precipitation, that is a extreme event for the precipitation. Now whenever these two events are happening at the same time, that is called compound extremes. And whenever happened in the monthly time scale, we have mapped it for entire for the Bhopal region from 1958 to 2022, I think. So this is how it. No, it is actually dry. Yeah. So 70 percentile above, that is hot extreme. Extreme temperature. That is dry condition. Drought. Drought and hot extremes. So that is basically drought and hot extremes we are considering, and where we are calculating all these different values. So if you look at here, it tells you about after 2000 we are seeing more frequent occurrence of these compound extremes in the Bhopal districts. That is what we are observing from our data analysis. Before that, there are some occurrences there, but not that frequent one which we are observing like that. Now you can see that since let's say here 1999 or something like that to 2010, we have very frequent occurrences. Even every 3 months, every 4 months, we have this kind of compound extreme conditions. Yeah. Yeah, you can do P20 and T80 also. Yeah. When we are, yes, there is not any specific rule as such, but you can take whatever the literature in this particular field suggesting that as you are moving towards more extreme conditions, for example, if I take here P90 and P10, that is more extreme. In that condition, you will have very few occurrences of compound extremes. So as you are moving towards the more extreme condition, that is the extreme level. And then there is a moderate, there is a severe, then very high, then severe and moderate. Like, so it is somehow. So if you are enhancing your threshold moving forward, you will have lesser number of compound extremes. If you are looking at, let's say, Indian scale, 1 degree is good for India. But if you are using for the data for the Bhopal and all the districts, here we have not used IMD. It's a different data set, Terra Climate. This is? This is reanalysis data set. Yeah, but it is also they are taking some information from the gridded data or station data also. Terra Climate. Terra Climate. So Terra Climate has data is 4 kilometer. 4 kilometer grid. So that is why. For this Bhopal, we are able to get the data for Terra Climate, multiple grids. So basically this. What is occurrence means? मतलब उस दिन हुआ है. That is one. One means that event occurred. So this is the monthly data. This is a monthly data. In which month we have seen this condition is true. We are plotting 1. If it is false, that is 0. What is the false condition? Let's say both the events not occurred. That is false. Yeah, either of them were occurred. Either of them was occurred. That is basically a false condition, because for the compound extreme we need to have both the conditions should be satisfied. Then it is 1. So that is how basically we have tried to IMD has 25 kilometer resolution. IMD has 0.25 degree. If you 0.25 degree means 25 kilometer. So that is a very coarse chips. So that is fine resolution data, but we were looking at only monthly scale, so I think this is the best one we found. And there are some literatures were also published which are giving you the best data set. You can use many data, but think whenever selecting the data set, you should make sure that there is evidence that that data is useful for your study. So this is basically we are able to find out the pattern, and based on that we have classified, we have marked those events which has happened in the Bhopal. That is a kind of a compound extremes. And based on this methodology, first you have to basically identify the extreme conditions. Then you have to basically calculate the 30th to 70th percentile like that. And then you have to basically do some sort of true and false analysis, 0 and 1. If both the conditions are satisfied, that is 1. And based on that you can count the numbers. Now you can do multiple analysis from here. You can calculate what is the total number of occurrences between different decadal wise, or let's say you can also calculate what is their inter-arrival periods, है ना, कितने month का gap आता है, what is the average inter-arrival period for every 10 decades. Here we can also fit. When you are talking about 0 and 1, then you are talking about primarily Poisson or some other kind of the distributions which are dealing only the true and false. So that's a very specific type of distributions we have. So here basically you can classify these compound extremes, and then based on that you can tell about the pattern, and then you can also correlate with this pattern with your large scale phenomena, for example INSO or La Nina, or some sort of local phenomena, deforestation or extreme climatic events like that. So this is how basically you can correlate these compound extremes with different phenomena. Which slide? 10. For example, let's say you are so in the hydrological field, or generally we consider 30 years is a good record. 30 years is a good record, है ना? So therefore, if you divide our data into 30 years time period, that is tell you some sort of long term processes, है ना? If you take only 5 years, it is a short term fluctuations, but when you are taking the 30 years, it is sort of long term fluctuations. So if there is a significant change in your processes, so 30-year record will tell that information more clearly. Suppose 1901 to 1930, there was very minimal effect of absence effect of this anthropogenic activity and all, purely natural system. 1931 to 1960 same. Then 1961 to 1990, there is significant rise of the land use, land cover conversion and industrialization like that. So when you divide your data into 30 years realization, you will yeah, you can do that. That can be also be, but 10 years difference might not get you very soon. Yeah, that we can also test. We can also test whether there is a significant change in the data set or not. So the major point is here is that when you divide your data into different realizations, you try to look at the distributions of the data or statistical property of the data, whether it has been changed or not. Sometimes it is we observe that there is a change in the mean behavior, but the standard deviation is remain same. Sometimes we observe that there is a mean behavior is same, variability has been increased. Okay, the standard. Good amount of, yeah. Any more questions? So you got the whatever I delivered, the compound 16s, everything. If I give you data, you will be able to calculate. 3072 देखो इसका कोई गाइडलाइन नहीं है, ठीक है. हम कंपाउंड एक्सचेंज में जो काम कर रहे हैं ना, अब कोई कहेगा कि हम इसको 25 और 75 भी कर सकते हैं, ऑफ कोर्स कर सकता है. हियर वी आर नॉट क्वांटिफाइंग द एब्सोल्यूट नंबर, वी आर सेइंग दैट दिस अमाउंट ऑफ एक्सट्रीम्स हैज बीन इंक्रीज और डिक्रीज्ड, है ना. अगर हम इसको दूसरे टर्म्स में बात करें तो लेट्स से वी आर यूजिंग सम सॉर्ट ऑफ 15 और 20 डिस्ट्रिक्ट्स एंड वी आर ट्राइंग टू फाइंड आउट विच डिस्ट्रिक्ट्स आर मोर वल्नरेबल या हम वल्नरेबिलिटी इंडेक्स जो निकाल रहे हैं या सीवियरिटी इंडेक्स, इट्स अ रिलेटिव टर्म, राइट. सो व्हेन यू आर यूजिंग 10 और 90 और 20 80, इट डिपेंड्स कि हाउ फ्रीक्वेंट इवेंट्स यू वांट टू कंसीडर इन योर डेटा सेट. If you are using 30 and 70, you will have more events. So that is basically defined by the threshold, which basically tell you about that event is flood. That should be. So here it's a very simple. So P30 is your threshold. When you're talking about the flood, it is that threshold where above that value will cross and become flood. It could be your danger level, it could be your danger level, या flood level, it could be like that. It depends upon site to site, HFL or danger level, like that. सबसे सिंपलिस्टिक अप्रोच यही है. कर सकते हैं. लेट सपोज हमने इमेजिन किया कि अगर हमारा जो रेनफॉल है वो क्यूमुलेटिव 10 mm से कम है. That is the absolute value, right? And we are saying that at the same time the temperature extreme goes beyond 45 degree. That is a one threshold. It depends. अब हम चूरू की बात करेंगे राजस्थान में तो 45 डिग्री जाना वहाँ पर कॉमन है, ठीक है. अभी मैं भोपाल की बात करूँगा या लेट्स से हम ऐसे एरिया की बात करेंगे जहाँ पर 40 डिग्री इज एक्सट्रीम कंडीशन. तो it depends upon your region to region, which region you are applying this algorithm. In some sense you can generalize, but yes, if you are using different regions, of course there will be consideration of the threshold selections. इसका इसमें लैग हमने नहीं लिया ना. इसमें हमने केवल इवेंट्स ये कैलकुलेट किया है कि जो एक साथ आए, देयर इज नो लैग. P70 and P30 which is occurring at the same time, that we are considering as a compounding states. हाँ, in the same month. T-1 T+1 को हमने नहीं कंसिडर किया, but that can be also be considered. This is a cascading effect. Any more questions?